Was them the favorite of your grandparents?
Oh yeah, Hallie. My sister Hallie for sure was Grandma and Grandpa Taylor's favorite.
Wasn't she the youngest?
Yep. Faux show.
You know how like a 7-year age difference?
Yeah, we're pretty far apart. Okay, so a central angle in a circle is an angle where the vertex is the center of the circle. That's why it's called a central angle, because the angle starts, the vertex of that angle is in the center. Since the vertex is in the center, that means the sides of the angle, by definition, are the radii of the circle. Now, this particular circle that I drew for you here has actually got 3 central angles. I only labeled one of them. What's the one that I labeled? What's the name of the angle? EDG is a central angle. And the measure of angle EDG is 57 degrees. I touched on this a little bit in our last lesson about parts of circles, but the relationship between central angles and the arcs formed by those angles is equal. So this arc right here, arc EG, which is formed by the 2 radii DG and DE, the arc is also equal to 57 degrees. So not only is the measure of angle EDG 57 degrees, but the measure of arc EG, which I do like that, arc EG is also 57 degrees. Central angle and the arc formed by that angle are congruent. What's another central angle that I have here? EDF, very good. EDF is a central angle. And if I make the assumption that FG is a diameter, what would the measure of angle EDF be? 180 minus 57. Close. 120. So this will be 123 degrees.
Wait, hold on. The circle's 360.
Uh-huh.
When do you subtract it by 360?
No, because arc FE is not the rest of the circle. Arc FE is the rest of the semicircle. I would subtract it by 360 if I wanted to know the measure of arc EFG. There is one more central angle here. What is it? FDG. Again, making the assumption that FG is a diameter. What is the measure of angle FDG? 180. Which means it is equivalent to the measure of arc FG. Now, just for fun, we can figure out the measure of arc EFG by doing what Peyton suggested, which is 360 minus 57, which would give us 303 degrees. Why do I have to call it arc EFG? Why can't I just call it arc EG? I love that you're saying little one and big one. I am unfortunately going to need you to use the actual geometry vocabulary. Well, then hopefully someone else in the class remembers it. Minor, thank you. The minor arc and the major arc. The minor arc and the major lift. It's cold and it's broken. Hallelujah. Hallelujah. All right, let me give you another one. This is going to be central angle ACB. AC/DC. My favorite way to get electricity into my house. Okay, Rock Band, excellent electric current variant. Couldn't live without it. So, this is called the angles, chords, arcs congruency theorem. Yes, the angles, chords, arcs, congruency theorem. And here's what it says. If I have two central angles that are congruent, so we'll say angle ACB and angle DFE are congruent. That means that their arcs, their intercepted arcs, must also be congruent. So arc AB is congruent to arc DE. So if the central angles are congruent, then their arcs would be congruent. And here's the chord part. Their chords are congruent. So if I were to draw a chord, is there a better reason to draw a chord than because I can?
I mean, if you're playing a song, then yeah. But in circles, no, there's no reason.
Yes. Oh, I get mixed up. Which ones are the diddly doos and the diddly don'ts?
These are the diddly don'ts. The ones in.
So from this diagram, we can learn three things. 4 if your camera's turned on. You can see one of the things you can learn is, even with most of his face covered, my math teacher is ridiculously handsome. But one of the things you can learn is that congruent central angles have congruent chords. You can learn that congruent chords have congruent arcs. You can learn congruent arcs. Have congruent central angles. And finally, you can learn a handsome math teacher makes it easier to concentrate.
Well then, oh well, I can fail that. It's on the test. And
3 of those things we can learn from the angles, chords, arcs, congruency theorem, and the 4th one, I think, kind of obvious.
Yeah.
Well, this is fun. I can't say it.
It's fun and easy to concentrate on.
Which part?
Let me draw you 2 completely perfect circles that are exactly the same size.
I feel like you're doing this on purpose. He is.
Well, I mean, yes, I'm drawing them perfectly on purpose so that it will be easier for you to learn.
You call that perfect?
Yes.
That looks like a hard-boiled egg that just came out of the oven. Yeah, the fryer.
Why would it be in the fryer? Do you know what the boil in hard boiled means?
Sorry.
You said oven and fryer.
A hard boiled egg that just came out of the oven. No, just kidding. The fryer. I love it when somebody tries to roast me and just totally blows it. That, my friends, is called instant karma. Respect your math teacher.
The computer?
We can't use that joke anymore because they don't actually teach us now.
We take our quizzes on it.
This is a very hard thing. You pick like the weirdest diagram ever to draw this with.
You think this is the weirdest diagram ever?
Well, it's hard to replicate.
Which you've drawn so far.
It's hard when you've drawn thus far.
Brock has a good point. My mathematical aura protects me from roasting attempts.
Oh, like Peyton's dance and extreme lack of entertainment options ball.
That's true.
It all
It's
makes
the fear of
sense
a hitter that she'll chase us like that.
Mhm.
now. Oh my goodness, this is Taylor.
See, that's perfectly good circle.
What have I done?
Yeah.
Like in life?
What have you done to this problem?
Pretty much nothing.
Yeah, that's obvious. You're a high school math teacher.
I give and I give
I can't see.
and I give.
This.
Ow!
How does this work?
Beats me.
language.
Are you telling us something?
So the first thing that I'm going to do is label what I know. I know, for example, that the measure of JOK is that thing. So this is JOK right there. And I know that FHG is that thing.
Oh, this is so fun.
Okay, what can I do?
Would those two things be congruent?
They are congruent because I put the little diddly doos there.
You could set up a little equation thingy. With 7x.
A little equation thingy.
Yeah.
That's true.
That was just wrote. That's the little equation thing.
That is the little equation thingy.
What's it on? What's it there?
I'm saying the way you said it.
Now what?
Solve.
Solve for x.
So you move the 6 onto
8x.
the other side.
Wow, what the? Can you do it the other way when you subtract
Then you end up with
3?
negative.
Yeah, you can, but you end up with the negative. Emily's right. You'd have, if you did it the other way, you'd have negative equals negative, which is fine. We ain't scared of negatives.
Subtract the 7x.
Yep. I ain't afraid of no negatives.
That equals x.
So 9 equals x. Whew. And we're done.
No, you have to subtract.
We're not. Oh man, because what do we have to find?
You have to find the arc of
Arc GF, which is this guy. So we're going to come over here and we're going to do 8x minus 6. And we just figured out that x was 9. So that's going to be 72 minus 6 equals 66 degrees. And speaking of 666, how are you, Miss Serta?
Oh, I'm great. Hey, I was wondering, for Boswell, did he complete part one originally? Like, did he get into it whenever he came? I know it was like
For algebra 2?
for like any of this.
Yes. Algebra
He
2
did.
was done in January, but the rest were
Well, I
completed in
remember
December.
that. Oh, okay, so he did complete part one with us. So the grade
Yes.
that he has is from us. It's
It does not include the transfer grade. It's just what
awesome.
he got with us.
Thank you.
Can you hold on? Because I'm not finished yet. And you're going too fast and it's bugging.
Maybe it's because you're spending a lot of time flapping your jaws instead of writing.
I am writing.
I like this stuff.
Yeah, it's not bad. Oh, I was just looking at the next problem. I don't want you to think that I was waiting for you. Let's draw another cool picture.
Sorry. What's the right triangle?
I don't know.
Based on how you said that, I'm gonna guess yes. It is the right triangle
How do you know?
because the tangents only go at one point,
Mm-hmm.
and for it to be a diameter, then that means it has to be a straight line. So
Mhm.
for it to hit that spot, it would have to be going at a 90-degree angle.
That's exactly right. It's called the radius tangent theorem. The radius tangent theorem says the tangent line to a circle is perpendicular to the radius.
Cool.
So you are exactly right.
So wait, so what's that little, what's the target point? And what's that target or goal?
Yeah, circle C.
Radius tangent theorem?
The radius tangent theorem. We'll go ahead and jot it down over here. The radius tangent theorem. Tangent to a circle is perpendicular to its radius. The end of that definition is probably at the point of tangency, but you get the idea. So it turns out finding the measure of angle dBA is actually super, super easy.
You just take 90 plus 37 and subtract that from 180.
Yep. Take the 90 and 37, which is 127, and subtract it from 180, which is 53. Okay, are you ready for something awesome?
Yes.
I don't know, Riley.
Good answer.
That looks like a sun.
It looks like he's wearing a hat.
I have to about to fall out. Still.
This problem is awesome.
It looks awesome.
It's so awesome we should call it Taylor. I'm just kidding. There's only one thing that's that awesome.
Mrs. Taylor.
Well played.
wrong with circles.
Well, we are working with circles.
I know that.
Because we do a lot of triangles when we're working with triangles.
Now we're doing circles and triangles at the same time. Okay, so what can we do?
Well, that's a right angle.
It is because we were told that it's tangent. So the radius tangent theorem says that's a right angle.
Ooh. So that gives you that angle. And so then you have a you would have to use your Sokotoa stuff.
I'd love to, but I don't know any angles.
Well, you know one, but the one you can't use.
Mm-hmm. Hmm?
You know the side length?
Do I know the side lengths?
A side length.
I have a question.
Yep.
What's that? Is that an S up at the top?
Yes.
Can you do opposite?
Definitely need you to pay more attention when people say things.
You look disappointed in us.
You mean because someone made a suggestion and I said we don't have enough information and then someone else made the exact same suggestion? A little bit disappointed.
How does Indian?
It's worth pointing out that whenever a problem is written like this, the 4 refers to just that piece. The R refers to just that piece. So how long is this piece?
Same as R.
It's also R, right? They're both radii. So I kind of know all 3 sides. There's a variable in there, but I have measurements for all 3 sides of a right triangle, which means I can use the Pythagorean theorem. That's exactly right, Peyton. A squared plus B squared equals C squared. The only one of these that's going to look just really awful is C squared. A squared, I'm just going to use R, so R squared. B squared, I'll use 6 squared. What's C going to be?
4 plus R squared.
Yeah, I'm going to do R plus 4 squared.
Can you just?
If you say R squared plus 16, I'm going to flip over this desk and
I
come at
wasn't
you.
going to.
Proceeds to say it. R. Why don't you use
Choo choo.
it's that polynomial stuff, right?
Mm-hmm.
So
R plus 4
I think
squared
this is
means
wrong,
R plus
but-
4 times R plus 4. You think
I
it's wrong?
But I got R squared plus 2R 8. I think that's wrong. Plus 16.
You are right that that was wrong,
Yeah.
but you were really close.
I don't think I'm really good.
When I distribute, R times R is R squared.
Wouldn't it be R squared plus 8R squared? No, plus 8R plus 16?
Yes.
Okay.
4R plus 4R just gives me 8R. So it's R squared plus 36 equals R squared plus 8R plus 16. Now you may be looking at this problem and thinking, my God, why have you forsaken me? I have to solve things that have R squared in them. But calm down. Because the very first thing that I'm going to do is subtract r squared on both sides. Which will leave me with 36 equals 8r plus 16. And voila.
We no wait, we're not done. Don't we have to subtract? No, we don't. Do we? Subtract 16.
Yep.
Both sides, and then we divide by 8. Then r equals.
Like 2.5, right?
2.5 is fine. I think I'm probably going to leave it as 5/2. But if you wrote 2.5, it would not be the end of the world. It's definitely not the weirdest way you've ever written an answer in this class. That's a pretty good problem. Sounds pretty good.
That was fun.
Any questions from anybody about anything?
Is that all that we're doing today?
No, it's 9:05.
I'm saying in math.
No, you have an assignment to do.
Good job.
Does anybody have any questions? Other than, am I done with school after 40 minutes? Beautiful.